Question 4. A company claims that a quarter of the bolts sent to them are faulty. To test this claim, the number of bolts in a random sample of 50 is recorded. Give 2 reasons why a binomial distribution may be a suitable model for the number of faulty bolts in the sample. Well, if we think back to the conditions for the binomial distribution, firstly, we need a fixed number of trials, which we do have here, and we need a constant level of probability. So we think back to the binomial distribution and the criteria. We're going to need a fixed number of trials, which we have here at 50. We need a constant probability, which we have here as a quarter. And we need it to be binary, as in 2 possible outcomes. And those outcomes will be either it's faulty or it's not faulty. Okay, so next we're asked to use a 5% significance level with the model of a binomial distribution, find a critical region for a 2-tailed test of the hypothesis that the probability of a bolt being faulty is 0.25. The probability of rejection in each tail should be less than 0.025. Okay, so quickly let's look for some clues in the question. 5% level of significance, good. 2-tailed test, that's going to be important. It lets me know what to do with my alternate hypothesis and my significance level. All right, and we should be good to go. So let's start with the null hypothesis. The null hypothesis is that P equals 0.25. The alternate hypothesis, being a 2-tailed test, the alternate is not equal to 0.25. This null hypothesis is based on the fact that that X follows a binomial distribution where N equals 50 and P equals 0.25. That's going to lead to an expectation, let's just get that in there now, an expectation of 12.5. The significance level that we've been given is 5%, but obviously that's going to be split in 2. For both ends of the distribution. Okay, let's be careful to state exactly what X represents. Okay, and in this case, X represents the number of faulty bolts where P is the probability that a bolt is faulty. And we should be good to go to try and find that critical region. Let's just get a quick diagram for reference. I want the area in each of these tails to be 0.025, so the area and the probability. So I just need to identify what value would be the first one that has a probability of less than or equal to 0.025, and I'm going to verify that by also finding another value, 1, which has a probability above 0.025. Go ahead and try and calculate those. So either using the tables or calculators, let's try and hone in on some sensible values. All right, probabilities that X is less than or equal to 6. To 4 decimal places, that's going to be 0.0194. So that is definitely inside the critical region. Let's check one value above. So we're going to check X is less than or equal to 7. Doing this on your calculator, looking up in the table, we'll get the same answer, 0.0453. Okay, this is the situation we're looking for. One of them is less than 0.025, while the other is larger than 0.025. That actually lets me know that this value must be 6, while this one over here must be 7. 6 had a probability less than, and 7 had a probability that was more than 0.025. Let's do a similar thing at the top end. Probability X is greater than or equal to 19. 1 minus the probability that X is less than or equal to 18. 1 minus 0.9713, which leads to 0.0287, very close to the probability we're looking for. Let's check. It's greater than or equal to 20. I think we can predict what's going to happen here, but we do need to prove this is what will happen. 1 minus 0.9861, and that leaves us with 0.0139. good. Once again, this is the situation we wanted. One of them was below and one of them was above the 0.025. So I can deduce that 19 will be on this side, whereas 20 will be the first value into that critical region. So I've done the proof. Let me do some final stating. I was asked to find the critical region. Critical region is going to be represented by these two critical values, but I need the whole inequality. So x is less than or equal to 6 and x is greater than or equal to 20. That's what we need to state. So critical region x is less than or equal to 6, x is greater than or equal to 20, and I can unify those. Okay, so showing those steps, making sure we get this situation where one is above and one is below, making sure that we state the value of x and the value of p, what they actually represent in this question. That will be worth, along with the inequality statement at the bottom, that will be worth all of your marks.